So chapter 9, section 2, we are going to talk about geologic time in this section. We're also going to talk about another concept, earth science concept, in which we actually assign dates for rock layers or for rocks. So our first section, 9.1, was all about, let's just say, what order of events did they come in? Did they come in first, second, or third? Now this one is saying, okay, we don't want to say first, second, or third. I want to say that's a million. That's 2 million. So that's what this section is. It gets a little bit more in detail with those things. All of this information that geologists use, relative dating, and this other topic that I just brought up, it's called absolute dating, where we actually assign ages to things. We take all of that knowledge and we use it to develop what is called the geologic time scale. The geologic time scale is a model of the history of life on Earth. We use this as a reference to figure out, okay, when did plants show up? When did fish show up? When did the dinosaurs show up? When did they leave? All of this information is put onto a geologic time scale. You went on the internet right now, you can find tons of different geologic timescales versions, but you're always going to see events in the proper location. Paleontologists divide the geologic timescale into different divisions of time. The largest divisions of time are eons. Eons, you may have heard of that before when someone's like, oh, that's going to last an eon. It's the largest division of geologic time, hence the reason why people would use that as a slang expression. Eons are divided into eras. Eras are divided into periods, and then periods are divided into epochs. There isn't an exact amount for these. You'll notice if you look at them, if I look at even comparing the Cambrian and the Ordovician, they last different amounts of time. So how did they decide this? It's all about the life. When we look at life on Earth, when there is drastic changes in life on Earth, we switched to different time periods. So they didn't set it like how we have for our time now when we say, okay, there's 60 seconds in a minute and 60 seconds in an hour. They don't do that with geologic time divisions. It's based on how did life change. When you have changes in life on Earth, now we get divided into other things. So remember, eons are the biggest divisions of geologic time. Epochs would be the smallest divisions of geologic time. When you look at where do we live now, so we actually live in what is called the Cenozoic era. We also live in what is called the Quaternary period, which is actually not on this map that I see here, and it's also not it's called also, the Holocene epoch is what we're divided up into there. I like this geologic time scale. You can see it's got pictures on there. I can start to see how life is different, but once again, remember, it has nothing to do with time frame. It has to do with how did life change on Earth. Our first division of time here that we talk about is what is called the Precambrian era. The Precambrian era lasted from Earth's formation, so right when Earth first formed, until 542 million years ago. Earth, we think, is around 4.6 billion years old. Think about that, 4.6 billion years old. So when I look at this, 4.75 to 542 million years ago, that looks like that's most of Earth's existence here, right? Which it is. So if you look at a geologic time scale, even though when you look at the picture, that might look like a small division of geologic time there, really, this is where most of life, or most Earth has been in what was called the Precambrian era. This is when the first cells appeared on Earth. We believe there was this substance that we call the primordial soup. The conditions were just right where things came into play. And then things come together, and now here we are having the Precambrian era. Paleozoic era, 542 to 251 million years ago. Now I can see in this picture here, it looks like, okay, I don't just have these simple cells anymore. It looks like life is starting to get a little bit more complex. Paleo means ancient. That's why if you're a paleontologist, you study ancient life. So the Paleozoic is a Greek word meaning ancient life. This is when complex or more complex life first appeared and started to really diversify. So instead of having these real simple cells, now it starts to become more complex. And here we are actually seeing organisms like the fishes and plants and large insects all in existence. Another interesting thing is if you'll notice in the Permian period there towards the end, you notice how that doesn't look like a globe that we look at now today's. We're going to talk about this a lot in class. The continents at one point in time, we believe, were all connected as one giant landmass called Pangaea, which greatly affected life on Earth there. But when you think Paleozoic era, think, okay, this is when life took off. This is when things started to get more complex and started to get more serious. But still, even look at this. Look at the time frame here. 542 to 250 million years this lasted. This is a very long time period as well. Rocks from the Paleozoic era, you'll see fossils of snails, clams, corals. Another real interesting one that is really common from this era, it went extinct at the end of it, would have been a trilobite. And you see it in the picture there. They're kind of these really cool organisms where you see they almost look like they have this body armor on them underside, and they could be big. These are not, I'm not talking about little small things when we think of like an insect. These things are really, really big on Earth. Pterapsids also came into existence in the Paleozoic era. This is towards the end, you can see. It's that Permian period. Scientists believe these small reptiles are what eventually developed into mammals. The Mesozoic era. So Mesozoic means middle. Anytime, or meso means middle, sorry. Anytime you guys see meso, it means middle. And that comes up a lot in earth science. 251 to 65 million years ago. This is what is known as the age of reptiles. And who are the most famous reptiles on Earth? And that would be definitely the dinosaurs. So Mesozoic era, age of the reptiles. This is when dinosaurs roamed the earth. You can see the Mesozoic eras, the periods it's divided up into, the Triassic period, the Jurassic period, the Cretaceous period. Definitely when you guys hear those words Triassic and Jurassic, you're probably thinking dinosaurs anyways, Jurassic Park, right? But this is when dinosaurs were on Earth. If the dinosaurs are here and reptiles, start thinking about the climate as well. So the climate's going to be really warm. This is when Pangaea was here. All that land was connected. Lots of warm areas. Plants are really, really big. Notice it stopped at 65 million years ago. I'm going to go back here a second. I didn't mean to click through there so quick. So if it stopped at 65 million years, something must have happened. We believe at the end, at exactly 65 million years ago, we believe that a giant asteroid-like object hit the Earth, caused a large amount of debris to go up in the air, blocked sunlight so much that it dropped the global temperatures, killing a large portion of the reptiles on Earth. Dinosaurs, being reptiles, needing warm temperatures. If it's too cold, they're going to die. They're not going to have food either. So that is what marked the end of that 65 million years ago. It was a mass extinction in the dinosaurs. Now, if the climate's getting cool out, who's going to live? Smaller organisms that have the ability to not have to eat so much food. They can huddle in much easier. Maybe organisms that hair. That would be these guys. So after that came the Cenozoic era. That's the era that we are still currently in right now. So 65 million years ago to the present. This is what is known as the age of mammals. That's what we're living in. I mean, think about what is in the top of the food chain here, what's dominating things, and that is mammals. So fossils from the Cenozoic era are closest to Earth's surface, so it actually makes it quite easy to find. So now you can start to see really putting things in together a little bit more in detail here. So really start looking at, okay, this is when fishes came into existence. Look like we had fishes. Start to see more forest on Earth. Here's that Pangaea that I talked about. Dinosaurs, first mammals. Pangaea moved apart. The birds, flowering plants. And how do we know all these things? Geology. We know them from all of the topics that we're talking about in this chapter, looking at relative dating techniques, absolute dating techniques, and studying rock layers and studying fossils. And all of those things lead us to these conclusions.